In this video, we're going to do another limiting reactant problem. Let's do example 2 from your handout. We have what mass of iron oxide, iron 3 hydroxide, is produced when 10 grams of iron 3 sulfate react with an equal mass of sodium hydroxide. So first of all, let us write out an equation. So we're going to have the iron 3 sulfate reacting with some sodium hydroxide. So Fe2SO4 3 plus NaOH. This is going to be a double displacement reaction, so you need to recognize double displacement. And we're going to get some iron hydroxide here, iron 3 hydroxide. But then we have to write our other product as well, don't forget, because we have to write a balanced equation out. So if you don't write the full equation, you're not going to be able to balance it, and your stoichiometry is going to be off. So the other one is Na2SO4. Na2SO4. And as you already know, you could always check the states of your products. So if you look at your data table and you look at your solubility chart, the solubility chart states that the iron 3 hydroxide should be insoluble and the sodium sulfate is soluble. So it's one of those that produces a precipitate, one of those double displacement reactions that produces a precipitate. And we're asked to find the mass of that precipitate. And then these are going to be solutions. So let's say it says we have 10 grams of this. So mass is equal to 10 grams. And over here, our mass is also equal to 10 because it says an equal amount is reacting. 10.0 grams, sorry, because we want to make sure we follow our sig figs as we do that. So 10.0 grams. And we can't do anything more here because we need to find we need to balance our reaction first. So let's go ahead and do that. So I can put a 2 over here, and I can put a 3 over here, and then I can put 6 over here, and I believe this is going to be 1, and now we're nice and balanced. And our goal in the end is to find the mass of iron 3 hydroxide. So we need to do the moles of this times the molar mass. So essentially we have to find the moles of iron 3 hydroxide using one of the reactants. The problem is we don't really know which one to use. We have to find which is the LR. The reason I know this is because we have the quantities for both reactants there, and so they're making us pick. And we can't just pick any one because we don't know if they're reacting in perfect quantities. So this is one of those LR problems. And it's a little bit more involved because to find LR, you have to make sure you compare your reactants when they're in moles. So that means that for each of these, we need to have our molar masses. So I'm going to go ahead and just write that down. We're going to try to find our molar masses for each of these just so we have them ready to go, and then we're going to convert to moles after. So we're going to have these just in our little toolkit here. Find the molar mass of everything that you're possibly going to use. And then same thing here, molar mass of the iron 3 sulfate. All right, so I have my periodic table here with me, and I'm going to go ahead and calculate the molar masses that I need. So for sodium hydroxide, and you can go ahead and do this with me as well, 22.99 plus 16 plus 1.01, and I get about 40.00 grams per mole. For iron 3 hydroxide, I get 3.03 plus 48 plus 55.85. I get 106.88 grams per mole. And for the iron 3 sulfate, I have 12 times 16 plus 3 times 32.07 plus 2 times 55.85. And I get 399.91 grams per mole. And so what I'm going to do is I'm just going to convert the reactants, all of them, to their moles. So I'm going to get the moles of the iron 2 sulfate. So we'll have moles of iron 2 sulfate will be equal to the mass over the molar mass, which is the 10.0 grams over the 399.91 grams per mole. Cancel grams out, and we're left with moles. So 10 divided by that answer gives us, I'm going to write the answer down here. So about 0.025005626 moles of the iron 3 sulfate. And then we're going to do the same thing over here. We're going to find the number of moles of sodium hydroxide, which is, again, the mass over the molar mass, but it's the mass of the sodium hydroxide, so 10.0 grams over the molar mass of the sodium hydroxide, 40.00 grams per mole. And we get 10 divided by 40, which is basically just 1 over 4. We get 0.25 moles of sodium hydroxide. And so we have everything we kind of need. We have our mole values ready to go. We can use one of these mole values here to find the amount of iron 3 hydroxide produced. But we have to choose which one is our LR. So that's really our step 2. The step 1 is kind of setting everything up, finding moles that we need. Step 2 is let's go ahead and find LR. So step 2, find LR. And we can use any method that we want. So I'll probably just do the method where I'll do method 1, where I divide both reactants by their coefficients, and the smallest one is the LR. That's what I'll do. You can try any other one and see if you match up. So try method 2 or 3 and see if you get the same thing as me. And the next example, I'll probably choose another method. So for Fe2SO4, Fe2SO4 3, I'm just going to do the number of moles that I calculated, 0.025. I won't put everything there. I'm just going to put a few digits there, divided by 1, which is equal to 0.025. Now, over here, for the sodium hydroxide, I'm going to do the same thing. I'm going to take my number of moles, 0.26, divide it by 6, because it's the coefficient. And so I'm going to get 0.25 divided by 6, and I get 0.04166, and it keeps going. So now I compare the two values, and the smallest one will be my LR. It looks like the smallest one is going to end up being the iron 3 sulfate, since 0.025 is less than 0.04166, iron 3 sulfate is the LR. So we found our limiting reactant over here. And so now we can go and use our limiting reactant moles, which is a 0.025005626, and do a mole ratio with the product we want to find the moles of product. We can essentially ignore the NaOH because that's our excess. So this is I'll go label it as excess reactant, and over here, limiting reactant. And that's the one I want to use going forward. So for step 3, use LR to solve the problem. So we have a ratio of 1 Fe2SO4 3 for every 2 iron 3 hydroxides, because it's a 1-to-2 ratio. So we can take our moles. I'm not going to put all the digits in, but they're still in my calculator. Moles of Fe2SO4 3 times our ratio. So 2 moles of FeOH3 for every 1 mole of Fe2SO4 SO4 3. Cancel out moles of the iron 3 sulfate, and you're basically just doing 0.025, so on and so forth, times 2. And so that's going to be equal to your 0.025005626 times 2, and we'll get about 0.050011252 moles of the iron 3 hydroxide. So we found the number of moles. Now all we need to do is find the mass. And remember, the mass is going to be equal to the moles of our product times the molar mass of our product, which we already calculated over here. So that's going to be equal to 0.050. I'm not putting everything in there, but moles, it's in my calculator still, times the 106.88 grams per mole. Cancel mole out and you're left with grams. So times 106.88. And I get 5.3435202 grams, which is approximately, let's see how many sig figs we need. In the question, our LR, we use it for our calculation. The smallest number is 10.0, so 3 sig figs. And so we want to round to basically here. You look next door, it's not exactly 5, it's actually above the 5 there, so we can round that up to 5.35 grams. So therefore, approximately 5.35 grams of FeOH3 are produced. So my limiting reactant will run out. I'll have some excess NaOH, and later on we'll learn how to find that excess, but we'll produce, with a limiting reactant running out there, 5.35 grams of the FeOH3. So that was one example, similar to the previous example that we had done, but this time everything was given in masses. And so we had to do the same process, just convert everything to moles first, then try to find your LR. Once you find your LR, you can use that LR to solve the actual problem being asked. And then afterwards, you can convert it to what you need it in. So for example, in this case, I had to convert the moles of the product back into mass using our molar masses. So it's all the same skills you saw before, just a couple extra steps here and there. And it's mostly just the limiting reactant step that's a little bit different. In our next video, we'll do example 3.